is your typical Fred function. So a Fred function is just a random function. It has a different shape than your normal functions would. There's not a particular equation that goes with this. It's just a function, and you can grab a bunch of stuff off of it. So one thing I would notice off of this graph that let me zoom in one more time if I can. That the right-hand side, notice that this is a closed circle. So that means that it doesn't go on forever. It stops completely there. So it stops at a certain height and it stops at a certain length. But over here, it has an arrow. Now notice this is a line. So this is a line that has a slope here of 3. So every 3, I'm going to end up going up. So I'm going to map this all the way off the graph only because it has an arrow, which means that it goes on in that direction forever. And I'm going to go ahead and put an arrow so we know that that will go toward negative infinity. Of course, now I have to zoom back out. Even more than I thought. Come on, you can do this. All right, there we go. So let's just evaluate. Let's just see what we know. So if I'm looking at the top, definitely write this down somewhere. If I'm looking at f in general, and it could be capital, lowercase, whatever works. If I have f of an x, it's going to map to a y. So your input goes inside the function and your output is here. So that means that f of x in its entirety equals y. So f of x is the output, but x itself is the input. So for instance, if I'm looking down at number 1 and number 2, notice that this 5 is inside, so this is in the x position, and your goal is to find the y that matches. But if I look at number 2, I don't know the x value, but I'm giving a y value of 9. So before I start anything, I'm going to write a couple notes at the top again too. So anytime you're worried about x, x is the length. So how long is the function, which will go with your domain, and y will end up being the height. So how tall is it? How far does it go up? How far does it go down? But that's the extent of it. So if I'm looking at number 1 and it says f of 5, so number 1 says f of 5. So I'm going to go on my x-axis at 5. 1, 2, 3, 4, 5. I want to highlight it. I should have that out already. Later. 1, 2, 3, 4, 5, and I'm going to draw up, and wherever I hit my function, that is the answer to the question. So I hit at a height of 1, 2, 3, 4. So my answer for number 1 is 4. This simply means that x is 5 and y is 4. So if this was a solution set, 5 maps to 4, where 5 is the x value and 4 is the y value. It really depends on what you're looking for. So I will do number 2 just to kind of show you the difference. So on number 2, I have my height at 9. So my goal is to see when do I ever get a height of 9. So if I'm looking at my graph again, and this I have to zoom out a decent amount. So a height of 9. So notice on the right-hand side, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So this is 9 here, but nothing really hits 9 on this side. So what will happen is I'm going to draw it over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And when x is negative 11, it'll actually hit a height of 9. So negative 11 maps to a height of 9. So my answer for my x value here at the bottom is 11. If I look at number 2 and I want to go about this problem, notice that I can actually box this function in height-wise and length-wise, and it doesn't go on for infinity. So I know for sure for my domain and range section that you will have restrictions. It's not going to go off to infinity. There's actually a box I can put around it. So for my domain, again, domain is length. So domain-wise, I go left 1, 2, 3. So negative 3, comma, 1, 2, 3, comma, 3. And was I able to hit 3 and negative 3 on the head? The answer is yes. So I would bracket those off, and that would be my answer for my domain. So lengthwise, this function exists, or this graph exists, from negative 3 to 3. Range is height. So how far does this go down? It goes down 1, 2, 3, 4. So my first number, and again, it's lowest to high, so -4, comma, up 1, 2, 3. So this goes up to +3. Now, here is a very, very, very good question. Is this a function, yes or no? I will end up hitting here, and I will end up hitting here, but I can't do that. So in order for it to be a function, your x has to map to a unique y. What this is saying is that -1 is 2 and also -4. It can't be 2 and -4. It can only be one unique answer. So therefore, the answer to this question is no, this is not a function. It's function notation. So I'm going to write this at the top pretty big. So this is what we got. You have an x that you input that gives you your y. Y is also f of x, so f of x is the output. X itself, by itself, is the actual input. So if I'm looking at this, what is my x value that I need to input? If I'm looking, it says find g of -3. So this is my x, or my t in this case, right? So my goal here, and I'm going to write this kind of, draw it out a little bit just so you can see exactly what I'm talking about. Everywhere you see a t in this particular equation, I'm going to replace it with -3. Okay, so all I did in this is I rewrote it to say, okay, whatever goes in here automatically goes into the t value here. So all you're doing is replacing the t. So my input here is -3. So my t, I'm going to input -3. And then from here, I'm going to take this and I'm going to simplify my answer, and then you get one numerical answer, which is not bad. So what's -3 squared, or -3 times -3? +9, very good. 9 times 3, 27. 27 minus 3, 24. So this final answer is 24. I want you to write it. G of -3 equals +24 as your final answer. So everything that you do in terms of solving has an input and output option with evaluating. So you're going to tell me what you evaluated and what that number ended up being. So the same thing as x equals, y equals, a equals, b equals, c equals, but this is how you should write it at the end. Number two. Okay, so here we go. I'm going to input -3 where n is. So I'm going to say w of -3 is equal to absolute value, and I kind of get aggressive with it, and I just make sure that you know it's not an L or a 1 or something. So just FYI, mine's a little ridiculous. That's why. -3 times -3 absolute value minus 2. So I need to look at this first part here. What is -3 times -3? 9. Now, does it matter in this case if the 9 was positive or negative? No, because if this was a 9 or a positive 9, when I take the absolute value of it, what's the answer? +9, right back out. So I will write it just so you can see so you always combine inside first. So I'll get +9, absolute value 2. What is the absolute value of +9? +9, and what's 9 minus 2? 7. So W of -3 equals +7 for my final answer.